All right, welcome back, everybody. Time to find a seat. We're joined now by Matt Swann. Now, if you were to give Matt a nickname, some people might say like the Cold Stone Killer or something like that, but I've heard other people call him the InfoSec Mr. Rogers. He's like the nicest guy you'll ever meet, but an incredible role model. He's also a great example of somebody who just gets stuff done. He's rolled out with his team, rolled out a bunch of incredible things in O365 and SharePoint Online, and we're going to hear about it today. Let's give him a hand. Welcome him.
Thanks, Lee. So my name's Matt. My team's responsible for securing customer data in SharePoint Online and Office 365. And as we've worked on this problem for the last 5 years, we've discovered that we have a challenge. One of which is that our clickers sometimes don't work. But as our service has grown, the scale of our service has outpaced our ability to do incident response. Because when we look at our service, the way that we used to do things no longer works, right? I used to run a script across thousands or tens of thousands of machines to gather data or make a change. I used to run a Cosmos query or an HD Insight query to evaluate my event logs and track an adversary the same day that I found him. But now I've got 200,000 plus machines spread across multiple domains with no trust between them, or sometimes in a domainless environment where running a script and assuming that I have implicit service account trust across all those machines no longer holds true. HD Insight and Cosmos has failed me because I have 15 terabytes of event logs every day, and I can't query those rapidly enough to keep track of my adversary. So my team has been forced to build 5 superpowers that has allowed us to scale our incident response capabilities as our cloud has scaled too. And so I want to share those with you today. So the first one is inventory. And I know nothing makes your heart beat faster than asset inventory, right? When I think of this, I think about like a barcode, and I'm putting labels on all my physical hardware, keeping track of who has it and where it has gone. But I want to challenge you to think about this in a different way. Really, the question that we're trying to answer here is how confident you are about the security health of your fleet. Imagine WannaCry, right? All of a sudden, it was very important to all of us to know whether SMBv1 was enabled or not. We all quickly went to Stack Overflow, found the registry key that told us whether that was on or not, and then tried to figure out, well, how do I run that query across all of my fleet, all of my test instances, all of my cloud, all my dev workstations? Suddenly, inventory became incredibly important. So we looked at this after the fact, and we said, one of the things that is challenging to us is, we're not even sure we know how many machines we have, but we also don't know the state of all of those machines. So we built a little agent. We distributed it across the machines. And we said, I'm going to give these agents questions to answer. I'm going to give them WMI queries. I'm going to give them registry paths. And every hour, I want each agent to wake up on a random interval, pull down those list of queries, answer them locally, and push them back up to a document DB in Azure Cloud. And this empowers a couple of things. One, it means that in that WannaCry scenario, my engineers can add a query, wait an hour, go back, do a query, and find every machine that is or is not compliant with a standard. 2, this allows us to build historical models and track the state of our fleet over time. So for instance, if I were to take a snapshot of this state every hour, put it into a database, query that, and say, show me machines that have been persistently unhealthy for the last 48 hours. In my environment, I constantly have VMs spinning up and being torn down. So at a slice in time, I don't necessarily know whether that machine is unhealthy because it's been on the network for too long and things have started to rot, or whether it's a brand newly deployed VM and it just hasn't finished being provisioned yet. So I need to be able to look historically over time to determine whether something should be cleaned up or not. But the real power here, when you have inventory and when you have state, is the ability to auto-heal. And so we've built an auto-healing workflow that runs 4 times a day, queries our system looking for machines that are unhealthy, and then tickets them for remediation, not to humans, but to an automated system. So if they're a VM, they get torn down, paved, spun back up. If it's a physical machine, all the VMs that it hosts are evacuated, and that machine is imaged. And so this helps us make sure that our environment is evergreen, it's always healthy, and as we add new health metrics, those accrue to our auto-harvesting system here as well. Now, as someone astutely pointed out in the OS query presentation this morning, the challenge with agents is how do you know when the agent isn't installed? How do you know when the agent isn't healthy? So we had that problem too. And what we did is we taught our agents to scan each other on the network. So we took advantage of a fact that we knew about our environment, and we said for each agent, for each IPv4 address that it's listening on, I want you to scan everyone else in that /24 subnet. And I want you to do that once a day at a random time during the day. So if the subnet is fully saturated with agents, we're going to get about 10 scans an hour. And the scan's going to do something really simple. Each inventory agent listens on a port. The scanners try to connect to that port. If it's present, it says, great, the inventory agent is running on this machine, and the inventory agent, when it responded, gave me back the machine name and the domain. So I can build a list, an inventory of everything local to me on my same subnet. If the inventory agent did not respond, I'm going to try 3389, RDP. I'm going to try SMB, because I want to know whether this is a Windows machine that's alive on the network but not running my inventory agent. And so what I get back is every about 10 times an hour, and at least once a day, if there's one machine on this subnet running my agent, a list of every IP address in my local subnet with the machines that are running the inventory agent and their names and domains, and the machines that are not, the machines that are online but unhealthy. And so I can ticket those for remediation too. As we built this capability, we also realized, that list of machines and list of subnets that are associated with them, the domains that are associated with them, is also giving me all of the information that I need to configure my Windows firewall. Because now I know for each /24 subnet which domains it hosts. And so I can say, hey, inventory system, tell me all the subnets that are associated with the domain that I am so that I can trust them. And so we can push that information back down and build an auto-configuring firewall without having to have a master asset inventory list that is hand-curated as things join or leave the domain. So the next superpower we had to build was forensics. And again, the challenge here was trying to scale to the size of our environment. So when we get an alert, we don't want to go out into one machine or 100 machines or 1,000 machines and try to gather enough context to know whether this alert is a true positive or a false positive. So we really like agents in Office 365. So we already had a security agent that's running, listening to ETW, uploading security events to our cloud. And the first thing we did is we realized, I want to know ahead of time what the auto-start entry points are that are configured on this machine. I want to know all the local groups, local users, local group membership. I want to know which certificates are installed on this machine. So each agent every day is going to snapshot those and upload those to our big data system so that when I have an alert, I can go back, look at the state of the machine, and build some context. So that worked pretty well. And in fact, that actually drove detections. Because once we had a list of auto-start entry points from each machine in a system like Cosmos or HD Insight, it's the most obvious thing in the world to compare those machines one with another. And even though I don't have a spec that says what registry keys are supposed to be set, I know that a deviation in a security interesting registry key might be an indication of compromise. But not all information is small enough for us to feel comfortable just uploading it constantly. So the next thing we did is we taught our agent that when it uploads an alert, a real-time alert to one of my engineers, that it should also upload forensic results at the same time. So when I get a real-time alert, I want to get a list of everyone who's logged into the machine, all the processes that are running, maybe the list of DLLs that are loaded into each one of those processes. We call this X-ray. We want to get like a bill of health for that machine that I can use to evaluate that alert in real time at the time it's received. So I'm speeding up some of the operations that my engineer would otherwise have to do. Similarly, if we get an alert for a process, perhaps we want to take a process memory dump and we want to upload the executable associated with that process. Well, my engineers are then going to have to use a tool like PE Studio or Watson or WinDBG or Strings to try to do some initial malware triage on that. Instead of my engineers running tools, why don't I do that in the cloud? why not take every executable that I decide is interesting, send it through an Azure workflow that runs PE Studio and gives me a list of initial malware triage entities. So now, instead of my engineers spending time triaging each individual alert and digging into the ones that are interesting, or perhaps not even doing that level of research or involvement because it's time-consuming, that information is staring them in the face in the same place that they're already triaging alerts. OK, so we're triaging alerts, and we found one that's a true positive. I have 200,000 machines. It seems like the odds are pitched against me, because my adversary can choose to hide anywhere in that fleet, and I'm the one that has to track him down. And I've started to solve a couple of problems, right? I at least know that my agent is running and healthy on every machine, so there's fewer opportunities for him to hide. But I still have the proverbial needle in a haystack. So back to our fleet, back to our security agents. The first thing that we did here is we built an IOC store. And when I see IOCs, I don't mean hashes and IP addresses that we get from a threat intelligence feed. I don't mean some subscription that we sign up for that we automatically import and push out to the agents. These are IOCs that are gathered during real incident response. So for example, if the red team is in my environment, I get an alert, I investigate, and I discover that that red team malware is calling out to an IP address, I'm going to put that IP and that host name in my IOC store. Every agent is going to sync that down every 15 minutes. And the next time network activity or process activity occurs on that machine and matches that IOC, I'm going to get a real-time alert. And what's beautiful about this is that I'm not going to get an alert just from the one machine that tipped me off. I'm going to see every machine as it happens. So if my adversary moves from one machine to another, that will trip a new IP address alert or a new IOC alert. And so now, as my adversary moves laterally, I can see him at the same tempo that he's moving. Now, not all evidence can be gathered event by event. For instance, let's say I took that malware and I looked inside and I found that there were strings or a sequence of bytes that were unique to this malware. I want to know where else that is inside my fleet. So what we did is we taught our agent how to run jobs like a Yara scan. Yara is a pattern matching language that can be used to look for hashes or sequences of bytes in a file or in memory. And so we run a Yara scan across the fleet by defining the signature that we're looking for. We handcrafted this. It's bespoke hipster Yara rules that we crafted from our malware. We put it in the cloud, and we distribute that question to all of our agents bit by bit. Because we know that Yara scanning could be expensive. We're running a cloud service. Our engineers or our customers need to continue being able to get their job done. And so we distribute that across the fleet. And if we find a match, that alert gets sent to our engineers. Now, we tried this in a red team engagement last December, and what we found was that there's a virtuous cycle between this IOC system and this alert system, or job system. So we started with an IP address that we knew was bad based on an alert that we received. When we put that in the cloud, we started to get alerts from other machines that were accessing that same IP. So we used our forensic capability, pulled process memory dumps, investigated those, and wrote Yara rules to pattern match that malware. We ran a job to scan all the other processes across our entire fleet, looking for that malware, found more processes. And what's funny was that there were disjoint sets, the set of machines that were contacting an IP address that we knew was bad, and the set of machines containing malware that was associated with our red team or with our adversary. So when we investigate those other machines, we find other IP addresses because our red team knows that they need to have heterogeneous or redundant command and control infrastructure. And now I take those IPs, I put them back in the cloud. I wait 15 minutes. I have alerts from new machines. So this forms a virtuous cycle where I'm able to quickly scan my environment and uncover my adversary's tracks. But just like I need to be able to track my adversary, now I need to be able to respond. And this is really where the rubber meets the road. So I have TTPs, I have IPs, domains, processes, machines that need to be paved. Now I need to respond. So the first thing I'm going to do is I'm going to use those same capabilities. I'm going to use my IOC store and my job repository. As part of a coordinated eviction activity, I'm going to use my job repository to run what we call an inoculation job on every machine. So if there's an IP that we know is bad, we're going to add a static route for it on every machine. If there's a host name that we know is bad, we're going to sinkhole it by adding an entry to the hosts file. If there's a process name that is bad, we're going to add an image file execution options registry key so that it can no longer execute. Similarly, we're going to use our IOC store. We're going to add IOCs for all of these, but we're going to flip on an option so that when the IOC matches, not only do we get an alert, but that thread gets suspended or that process gets terminated. So now we're in active response mode, right? We're doing this, again, as a coordinated response, not onesie-twosie as we happen to learn things about the environment, because we don't want to tip our hand early. But when we're ready to evict, we need it to happen all at once, fleet-wide. And when we did this in December, we were overwhelmed with data. Data from machines that had started to call back, data from machines that we were doing eviction on, data from machines that we were doing forensics on. We're pulling process memory images. We're running strings on them. All of that output needs to go into a single place. So we learned how to put that all in Cousteau. Cousteau is a lot like Elasticsearch for folks outside of Microsoft. And Cousteau has this really nice property where I can query across multiple tables. So I can say, give me everything that is true about a given process or machine or username. But then we had another challenge, because our tools didn't know how to speak the same language. Okay? You know, in one instance, I might upload data about a machine name, and I might put the fully qualified name of the machine in one column, but another tool might upload the machine name and the machine domain in two separate columns. And so we had to go through a process of normalization, right, to define what is our schema, what are we going to call these column names, are they uppercase, are they lowercase, do machine names end with a period or not? We did the same thing for processes. We did the same things for users. And then if you see on the right, you know, we have some IP addresses as well. In one case, we call it an entity. In another case, it was an IOC match, so we know it's an IP. So let's pull those out too. Let's call those IP addresses. The value of doing this is twofold. One, it makes it easy for your engineers to query across this. And imagine now when you want to find out your list of assets that need to be remediated, you are a query away, right? Select star from machine names across all of the tables that contain my forensic data. That's the list of machines that I need to hand off to get remediated or to get paved. This also lets you build intelligent experiences on top of your data. When your data didn't share a common schema, you couldn't join it together. You couldn't do linked data analysis. You couldn't build a graph. But if you're using the same schema, now you can connect together everything relating to a given user, everything relating to a given IP address. And this allows you to go beyond just data in a table that you're making use of for forensics, but actually building intelligent experiences so that your engineers can start doing guided hunting and exploring your data all the way down to the raw data, as well as incorporating their forensic results as they explore. So in Office 365, in order for us to deliver on our accountability, to make this the safest cloud, we've had to defend our data with new capabilities that have scaled to the amount of machines, to the size of our fleet. And we know that if we don't do this, it's not just we who lose, it's our customers who lose. And so what I gave you today is 5 patterns that we've proven out, that we've found to be effective. If you had the opportunity to see Nick's talk this morning, he did a spectacular job of walking through how OS Query incorporates these same patterns, how they use them at Facebook, and how anyone can use them, because they're open source and they can be contributed to. If you're here inside of Microsoft and you'd like to learn how we're doing this inside of Office 365, I'd love to chat with you. We have a microservice and agent-based deployment that has worked really well for us. Or if you have your own technology, whether that's Azure Security Center or OMS, and you'd like to incorporate that as well, we'd love to chat. Thank you.
Great job, Matt. This is a great example of kind of the difference between basics and fundamentals, where fundamentals are the things that everybody would like to have, but there's obviously a vast range of skill. So we've got some time for questions. Does anybody have some questions for Matt? We've got mic runners at both sides. Got a question right there.
So I was very impressed. Let me just start off with a little bit of compliments. So it looks like you've scaled very well. How do you work with teams, for instance, customer incident response teams that haven't scaled as well, that are still operating at a slower pace?
Good question. So I'll be honest, we don't do a lot of customer incident response. The strategy there is to leverage tools like Microsoft Cloud App Security, where they've learned how to present interfaces that scale for customers. So the analogous version of this for a customer of Office 365 would be to import all of the audit events coming out of Office 365, out of SharePoint, out of Exchange, putting those audit events in a common schema like Cloud App Security gives you, and then being able to reason over that schema to say, you know, when I see an alert by a user on a resource, what else has happened on that user? What else has happened on that resource? And be able to encode that as rules that you can apply, and then be able to configure workflows that take action, so that rather than an individual SOC analyst having to go through those rules or those policy violations line by line, you're automatically taking remediation actions so that you can keep up with the scale of your organization, rather than, you know, burning down a SOC queue as folks talked earlier about.
And also, this is a great plug for the next session. Greg Foss will be talking shortly about doing log analysis and investigation of Office 365 online. We've got time for one more question. Does anybody have one? Oh, got one back there.
You mentioned static routing, black holing IPs. That's pretty seductive. It looks very simple. It turns out not to be simple. Did you reuse an existing model for that, where you've got some kind of cleanup? You know, you're concerned about the maximum number of IPs you might be willing to put in that routing table, or you know, what are the pitfalls there that you've encountered?
You know, we haven't had the opportunity to exercise that in a real incident response. We're building the capability right now. I like that you call out the pitfalls there. There are certainly services that depend on being able to make outbound calls to given IP addresses. SharePoint is not one of those. Customers make a request and we respond. And so the IP address or DNS black holing should have less of an effect in our unique environment. But you're right that there should be checks and balances there, so that an engineer can't black hole, say, all of the 10 dot space or all the 25 dot space. Thank you.
Great. Thanks, Matt. Thanks for your time. A great session.